Hello. So this is the last video of chapter 3. So in this video, I'm going to discuss measures of relative standing, which is a generalization of the median. Excuse me. So the idea of the median is to divide the sample into 50-50, into half and half, right? So in this histogram, for example, we choose the median here so that the red has 50%, blue has 50%. So, like to generalize this, you don't need to choose 50-50. It could be 10-90 or like 80-20. Whatever. You may change the probability on each side. So that's how we generalize our idea. So we call that percentile. P percentile divides data into P% on the lower side and 100 minus P% on the greater side, right? So, then the interpretation, of course, has to be different. The median was a measure of center. It tried to capture the center, but like for example, like different percentiles will be capturing non-central location, right? So we will discuss that like with examples later. So it tells where an observation stands, where the value stands relative to the entire distribution. So it's more like comparison within the distribution, where if this value is small or large. So for example, like 25 percentile will divide the sample this way, like 25 to 75. So it must be lower than the median. Remember, median is slightly above 0, but 25 percentile is smaller than 0 because it's 20 percentile, so bottom 25% must be on the lower side than the median. On the other hand, if you increase the percentage P, 75 percentile has 75% on the lower side and only 25% on the greater side. So top 25% value is the 75 percentile. So it is greater than the median. Greater than the median. So depending on this P, as P increases, the percentile will also increase. Median is 50-50, so like 60 percentile must be greater than 50 percentile. And 50 percentile must be greater than 40 percentile. Like that. And median is obviously median is 50 percentile. They are the same thing. So this is a measure of relative standing. Relative standing, and this relative standing is quite useful to deliver on information, especially when you are not familiar with the unit. Then if you are not familiar with the scale of the distribution, this relative standing measure can help a lot. So first, let me introduce a few typical percentiles. So percentiles are defined this way. Smaller than this percentile must be P%, right? Some special names are like, say, 0 percentile is minimum, and 100 percentile is the maximum, right? So it cannot go further. And 25 percentile and 75 percentile, if you divide the sample into 4 pieces, 4 equal pieces, then we call them the cut point as the quartile. So first quartile is 25 percentile, and third quartile is 75 percentile. So 50 percentile equals second quartile equals median. By the way, there are actually more than like different names: percentile, quartile, like quantile. What I forgot. I forgot their names. So if you divide by 10, divide the sample into 10 pieces, then it has its own name. So, but percentile is, I think, most general way to describe the these measures. Here is the example, like value at risk. So in finance, value at risk is exactly the percentile concept. So say, for example, when I say 10%, like 5% value at risk is 10%, that means uh, the worst 5% case is losing 10%, right? So it's bottom 5 percentile. It's 5 percentile is 5% value at risk. So, like for example, when you invest in an asset, uh, I don't know how volatile the asset is. Then to describe that, say, like if you invest like 20 times on this asset, one of them will lose 10%, something like that. So it tells you, more like understandable, easy to understand numbers. And similarly, infant growth chart. Say when I say 2-year-old boy is 25 pounds, actually I don't know. It's hard to understand if this boy is big or small. But if I say he's at 25 percentile, then it delivers that information, right? So 25 percentile means he's like smaller than the average, but not much, just 25 percentile, something like that. And when we describe inequality in our economy, one of the famous popular measure is 20/80 ratio. So it compares the bottom 20 percentile, like and 80 percentile. So 20 percentile is bottom 20%, and like 80 percentile is top 20%. How distant they are, how much different these two uh, ranks are. So it measures inequality. Also in test scores, test score, I don't know the scale of like tests. So then relative percentiles will tell how good the score is. Like say my score is like when I say my score is 100, but I don't know if it's out of like 500, 1,000, whatever. But if I say I am 99 percentile, that means I'm top 1%. So I'm super good. I'm very, very good. Something like that. So it delivers more information and easier to understand. So that's how we utilize generalization of the median, percentiles. And before finishing the chapter, I'm going to show you on Excel how to calculate the mean, median, and percentiles on Excel. So this is the data, 2010 state population data, and I already ordered from California to Wyoming. DC is included. DC is included in here, so numbers clearly given. And so most of you may know, but just in case if you don't know, if you have never used before, click Formulas tab and click Insert Function. It has many functions, and like there are many categories like finance, statistics, math, like database, engineering, information. But we are learning statistics, so statistical, and within statistics category, there are a lot of functions built in here, and you see average. That is exactly the average we would like to calculate. Like let's see what happens if you click OK. Then you have to enter the numbers, the entries. In this case, you may just put 1 and 2 like this, but this is not what we want. We would like to copy those data. To do that, click this. By clicking this, you can choose the where the data are. So click this and click and drag the area of the data and click back this. Then it tells you it specifies the range between B2 column B, row 2, and up to B52 B column B, row 52. So it will calculate the average. So this is average, the mean. Now, if you want to calculate the median, same thing. Click and find median. Median is here. Okay, and do the same thing. Now, what I'm going to do is I'm going to click this and I will hold Control Shift and press arrow down. Then it will automatically choose the area and click OK. Then this is the median. So these are the average and the median I showed you in the slide. This is how I calculated. Of course, at the time I rounded the number, but this is what I showed you. Now, if you want to calculate, say, 25 percentile, for example, then you can go to percentile function. But it's a little bit annoying, but there are two different functions: percentile exclusive and percentile inclusive. It means so when you divide 25 to 75, for example, 25 to 75 is not exactly dividable. Like the sample cannot be exactly 25 to 75. So it cannot be, it's not exactly divided. So at that time, whether you include or exclude will make a little change in calculating. I'm not going to explain the detailed formula, but no matter what you use, not a big problem. Let me show you exclusive formula array. Again, I'm going to choose the same data range. And here, k is a number between 1 and 0, 0 and 1. So, like, if you are interested in 25 percentile, I'm going to write 0.25. 0.25 is the, means 25 percentile. So then it returns this number, 1.5 something million. Now then, by the way, remember it was exclusive formula, and you may do the same thing. Let's compare what happens if you use inclusive formula. So range array is the same, and x is excuse me, my mistake. I chose a wrong function. Percentile includes this one. I chose this one, but not that one. This one is the function we are handling now. So choose data and 0.25. Then, so this is percentile exclusive formula, percentile inclusive formula. So as you see, they are different. It's a little bit different because the formulas are different. One of the major difference between the inclusive and exclusive data formulas are like this. So by the way, I'll show you this way. You can directly type so let's see what happens if you put 0. So if you calculate 0 percentile, theoretically it should be the minimum, but it exclusive formula does not give you any answer. It cannot calculate. The formula cannot calculate 0 percentile. But let's see. So if you use inclusive formula, it does return the smallest value. Compare this value to this one, smallest one. So inclusive formula can handle minimum and maximum, 0 and 1, but exclusive formula cannot. So, but in the end, other than that, does not matter, and like not a big problem. Both are uh, reasonable and correct formulas. Okay, thank you for watching. In this chapter, we learned many different measures of location, central location and non-central location. And in the next chapter, we are going to use those measures of location to define measures of variability. So it's the next chapter is a kind of extension of what we have done in this one, in chapter 3. Okay, thank you for watching and have a nice week. See you later.